Part D states, determine an equation for the path of the box that expresses y as a function of x and not of t, assuming that at time t equals 0, the box has a horizontal position of x equals 0 and a vertical position y equals 2 meters above the ground with 0 velocity. So given this equation, we have at t equals 0, x is 0, and y is 2 meters. So just to remind you, we have our acceleration in the y direction is equal to negative 1.5 meters per second squared, and it's negative because it's in the downward direction. And to solve this problem, you have to remember that one of the equations of motion are dy equals the velocity in the y direction times the time plus 1/2 times the acceleration times the time squared. So with this, we can say that dy is just y, and we have y equals, and for vyt, velocity is equal to meters per second, and time is equal to seconds. So if we multiply v times the t, that's going to be equal to meters per second times seconds, which cancels out to meters. So let's call vyt, let's simplify that to just y naught. So here we have y equals y naught plus 1/2, and we'll substitute our acceleration in, times negative 1.5 meters per second squared times t squared. So this is what we have this far. Let's simplify that. Y equals y naught plus negative 0.75 meters per second squared t squared. Let's apply this for the horizontal direction. We have our horizontal acceleration is equal to 2 meters per second squared, and the distance in the x direction is equal to the x velocity plus 1/2 times the acceleration in the x direction times the time squared. And we know that the velocity in the x direction is equal to 0, so that cancels out, and we have x equals 1/2 times 2 times t squared. And if we simplify this, we get x equals t squared. And with this, you have to recognize that t squared here can be substituted in for the t squared here. So let's bring back our equation. Let's bring that down here. We have y equals y naught plus negative 0.75 times t squared. And if we substitute this in with this equation right here, we have y equals y naught minus 0.75 times x squared. Times x. So the final answer would be y equals y naught minus 0.75x, and y naught is the distance in the y direction. Y naught is the direction in the y direction, and given we have that the y direction, the y original position is 2 meters, so that the dy is 2. So if we plug that into our equation here, we have y equals 2 minus 0.75 times x, and that's our equation.